Welcome to lesson P8. We're going to be talking about vertical and horizontal translations, specifically with absolute value functions. So officially our objective is to analyze vertical and horizontal translations in absolute value equations and graphs. So we're primarily going to look at this through absolute value equations, but what we talk about today with the translations will apply to all kinds of functions that we're going to talk about this year. Quadratic functions, radical functions, rational functions, all these things that you may or may not have already even heard of. What we talk about today is going to apply throughout. So this is one of the most important lessons we've done up to this point. The first definition is that a translation is an operation that shifts the graph horizontally or vertically. So it's going to take a graph and it's going to shift it up, down, left, or right, depending on what the operation is. And we'll look at what determines which direction it goes. The first thing we're going to do is just an example where we're going to graph two different absolute value equations and look at what that plus 3 does. So they are basically the same function, y equals absolute value of 2x, and then one of them has a plus 3. So what effect will that plus 3 have between the two graphs? If you can take a guess, take a guess. And let's see if you're right. So what we're going to do here is we're going to make an XY chart. Just to see if, we can see what happens with that plus 3. This is not how we're going to do the rest of them. The rest of them, we're going to see what the pattern is, see what the effect is, and then take a shortcut every time. We're going to pick these values for x. It's going to give us some negatives, some positives, and a 0. And then we're going to substitute those in for x and solve for y to get the other part of the ordered pair. -2 substituted in for x. 2 times -2 is -4. Absolute value of that is 4. Do that for the other ones. So -1 substituted in will make 2. 0 substituted in will make 0. 1 substituted in will make 2. And 2 substituted in will make 4. I'm now going to plot those points. For -2, 4 is here. -1, 2 is here. 0, 0 is here. 1, 2 is here. And 2, 4 is here. And then do my best to draw a straight line. Before we do the other one, let's quickly talk about what we're seeing here. Absolute value functions will be a V shape. They will have a point where the direction changes. That point is called the vertex. The reason why there's essentially two sections to the graph is because an absolute value can do one of two things to a number. The absolute value of a positive number has no effect. The absolute value of 4 is 4, for instance. The absolute value of a negative number will result in its opposite. So the absolute value of -2 will turn into 2. So that's why there's two different parts to the graph, because one side is where it was positive, the other side is where it got flipped. If this was just y equals 2x, the line would continue down this way. But because it's the absolute value of 2x, part where it was negative then starts flipping up. And that's where that break happens at that vertex. So let's take a look. If I do the same thing, y equals absolute value of 2x plus 3. All right, whatever. All right, so you got xy. So same x's, -2, -1, 0, 1, and 2. If I substitute -2 in for x, 2 times -2 is 4. -4, absolute value that is 4, plus 3 is 7. -1 goes in, you get -2, absolute value is 2, plus 3 is 5. 0 goes in, you get 0, plus 3 is 3. 1 goes in, you get 2, plus 3 is 5. 2 goes in for x, you get 4, plus 3 is 7. I'm going to plot those points. So -2, 7. -1, 5. 0, 3. 1, 5. 2, 7. what you should notice is each of the red points, as related to one of the blue points, is up 3. And when I go ahead and draw it, it is the exact same shape, just shifted or translated up 3. So the effect that that plus 3 had was it moved it up 3. Okay. That's a rule. That actually is a rule that will happen every single time. So another definition in order to understand this rule is what's called a parent function. A parent function is the simplest function with the same characteristics as the rest of the functions in the same group. If I go back to the example quickly, the parent function was the first function, right? And then the plus 3 is a function in that family. Because it's the same shape, it just got shifted. So adding or subtracting number like constants will not change what the parent function is. It will be the same shape. The coefficient here, if that was a 3 instead of a 2, then it would change the shape. All right, so that's what a parent function is. So let y equals x and y equals the absolute value of x be a parent function, and let k be a positive real number. Then a plus k on the outside means it moves it up 3. Or I'm sorry, moves it up. The last one moved it up 3, but plus k moves it up k. Minus k moves it down k. So plus is up, minus is down. Notice how we're also talking about linear functions here. We'll look at an example for a linear, but it does the exact same thing. So that's all you need to remember. Plus is up, minus is down. All right, so y equals absolute value of 5x minus 1. I'm actually going to change this to minus 4, just because it'd be too hard to see and too hard for me to draw if I'm just shifting it down once. We're going to shift it down further, so just change it on your paper. The parent function here is y equals absolute value of 5x. Well, how do you graph that without making an xy? I mean, you could make an xy chart. I'm not even going to bother because here's all you need to know. Parent function will always go through the origin because it hasn't shifted. There's no adding or subtracting, right? So it will always go through the origin. And then whatever that coefficient is, you're going to apply it like slope. Meaning, if it's 5, I'm going to go up 5 and then right 1. Up 5 and then right 1. That's only half of it. The other half would go up 5 and then go left 1. Make that V shape. All right. So that's y equals absolute value of 5x. But it was actually asking you to do absolute value of 5x minus 4. The minus 4, based on the rule we just talked about, means it's going to go down 4. So I'm just going to take each of the points that we plotted in the blue and just move it down 4. So 1, 2, 3, 4. This one's going to go down 1, 2, 3, 4. This one's going to go down 1, 2, 3, 4. This one's going to go down 1, 2, 3, 4. And this one's going to go down 1, 2, 3, 4. And when you draw it, hopefully you draw it better than I just did. It is the same shape in theory. It should look like the same shape. And again, I don't really have a straight edge I can use on my tablet here, but if you're doing this on paper, definitely use a straight edge and it'll look better than what I just did. But that's the idea. It's the same shape, shifted down 4. For this one, the parent function, that negative is part of the parent function. All that the negative does that's out front is just going to go upside down instead of up. So instead of opening up, it's going to go down. The vertex will always be the origin for the parent. So start there. And then there is no number in there. So it's as if the slope is 1. And again, that negative means it's going to go down instead of up. So down 1, right 1, down 1, right 1. The other side would go down and left, down and left. So that's your parent function. Why don't you pause now and try to do what you think the plus 3 will do. All right, so pause now and then come back. Okay, so let's check to see if you got it right. The plus 3 is going to move it up 3. So I'm just going to take those 5 points that I plotted and move them all up 1, 2, 3. And it should look like that. Well, I did an extra point, doesn't matter. Do your lines through that. And again, it's the exact same shape, up 3. Example 3 is the exact opposite. So I'm giving you what the translation is, and you need to write the equation. So for this one, it's y equals absolute value of 4x. If it's shifted down 5 units down means minus 5. So all I'm going to do to write the equation is start with the parent function that I'm given, and then do a minus 5. Okay. For part B, I know it's not an absolute value function, but it works the same way. Y equals 1/3 x. 3 units up means plus 3. So then the equation would be just 1/3 x plus 3. The plus 3 shifts it up whether it's a line or whether it's an absolute value function. I know we're focusing, the objective was here to talk about absolute value functions, but again, this is going to apply to a lot more than just the absolute value functions. So here's an example of where it's the same rules applied and it works the exact same way with a linear function. All right, so that was all about translating vertically. Plus is up, minus is down. Translating graphs horizontally, notice how the number that we're adding is on the inside. If it's inside the absolute value bars, that's what's going to be horizontally. Plus on the inside moves it left. Minus on the inside moves it right. So you look at this picture here. When it was plus and it moved it left, that's what you're seeing here in the blue. And again, we're just making up a number. H is generic. So it moved it some amount to the left, whatever H is. When it's minus on the inside, it moves it right. That's what you're seeing here in the red. Okay, so it moved it to the right. Let's take a look at an example with actual numbers now. So the parent function here is y equals absolute value of x. So you're getting rid of anything that's adding or subtracting, whether it's inside or outside. So the minus 5 there, we'll deal with in a second, but let's plot the parent function first. Y equals the absolute value of x, and every parent function is the origin. And then you just apply the slope. The slope here is 1 because there is no number. So you go up 1, right 1 a couple times, and you also go left, and that gives you the picture of the shape here. All right, so that's the parent function. What effect is that minus 5 going to have? Well, based on the rule that we just talked about, that minus 5 is going to shift it right 5. So every one of these blue points, I'm going to move it right 1, 2, 3, 4, 5. And then I draw my lines. Notice how it's the exact same shape. Shift it to the right 5. I know this one's got a different parent function, but why don't you pause it and try it? Because we did do a -1 previously, so give it a try. Pause it, and then I'll help you go over it after you try it yourself. Okay, so the parent function for this one is y equals the opposite of the absolute value of x. So that negative sign again is part of the parent function. So I go ahead and plot those points. They're going to be here because it always starts at the origin, slope of 1, and then opening down. So down 1 and right 1, and down 1 and left 1. All right, so I have the parent function now. When I go ahead and do the translation, that -2 is going to move it right 2. So move every one of those points right 2. Now the blue is the function that was given at the beginning. The red was the parent function. Again, same shape. Blue got shifted right 2 based on that -2 on the inside. Now you've got a graph. Now this truly is the opposite of what you did before. You have a graph, you need to write the equation. So it's telling you that the parent function is y equals the opposite of the absolute value of x. And it moved it left 3, right? Because that parent function, if it was on here, it would have been here, right? But it went left 3. So left 3 in an equation would be +3 on the inside. So that would have been the equation there. Okay. Example 6 is really just taking everything that we've done, the horizontal and the vertical, and putting it together into one. So the parent function here is y equals the absolute value of x. So let's plot those points. For this one, I'm not even going to bother drawing the lines in for the parent function. I'm just going to leave those points there. And then what I'm going to do is let's take a note of what's happening. So the +1 on the inside means left 1. The +2 on the outside means up 2. So I'm going to take every one of those blue points and go left 1 and up 2. And then from there, that is the graph of the equation that was given. Okay. This one, the parent function, is the opposite of the absolute value of x. So again, always start at the origin. In this case, the slope is 1 and it opens down. So it'll look like that. And then the +2, let's talk about what the translations are. The +2 is left 2. The -4 is down 4. So I'm going to go for each of those red points, go left 2, 1, 2, and down 1, 2, 3, 4. I'm going to do that for each of the other points. Left 2 and down 4. And that is my graph. So again, you kind of have the choice if you want to fill in the rest of the picture for the parent function. A couple of the examples, the directions said to do it, so we did it. I also wanted you to be able to see it, but moving forward, generally speaking, you don't need to also draw the parent function. I'm plotting the points so that I can move them, but you don't need to do that. There are 2 examples left. That's going to be your exit ticket. So posted on Google Classroom is a Google form where you're going to go in and answer those 2 questions. So I'm going to leave them to you to give them a try. So try them on paper and pencil, and then go enter them on the Google form on Google Classroom, and then that'll be the first thing we go over in class on Thursday. So reach out to me if you have any questions. Try the exit ticket, and then we'll go over that in class Thursday.